Hey, sixth graders, this is lesson 7-13 and is very similar to the previous lesson when we were converting different units of length. You guys remember that one? This time we're going to be converting different units of volume for liquids. And there are lots of different measurement systems for this. So we're going to go ahead and get started with this first section where we are working on metric units of liquid volume. So the most common metric units of liquid volume are capacity, or capacity, are called milliliters and liters. So we're going to go ahead and fill out the double number line, just like we did when we were doing length in our last lesson. So they're tied at 0, but when you have 1 liter, that's 1,000 milliliters. 2 liters is 2,000 milliliters. 3 liters, 3,000 milliliters, and so on. You get the pattern. So the end of this picture, we're showing that 7 liters is equivalent to 7,000 milliliters. So the first question is, what two unit rates relate liters and milliliters? Okay, so the unit rate is how many is 1. So 1 liter is 1,000 milliliters. So that's what we can write. We can say 1,000 milliliters makes 1 liter. So 1,000 milliliters per liter. And this would be the unit rate if you are at liters and you're trying to find milliliters. Then the opposite would be when we find the reciprocal of that. So 1/1000th of a liter is equal to a milliliter. And this would be if you have milliliters and you are trying to figure out how many liters you want. Then you would use the second unit rate. Oh, I circled bad. I went too quick and I missed my 1,000. Sorry, 1. Okay, so number 3 says, a can holds 344 milliliters of seltzer. How many liters is this? Find your answer in 2 ways, by writing and solving a proportion and by using a unit rate. Well, the way we can solve a proportion is saying we have milliliters versus liters. So milliliters, I know, is always 1,000 for every 1 liter. So 1,000 milliliters is equivalent to 1 liter. Now, on a proportion, I could say, in my story, it tells me 344 milliliters. So I'm going to put the 344 on the top, because everything I'm doing on the top has to do with milliliters. And then on the denominator, I'm going to put an X, because that's what I don't know. So I'm going to solve this by using cross multiplication. And we end up with 344 times 1 is equal to 1,000x. Well, I'm going to divide by 1,000 to make the x get isolated. And if I divide by 1,000 on the other side, we have 344 times 1 is just 344. So we end up with x equal to 344 over 1,000. And how do I write that so it makes more sense? Well, 344 is like saying 344.0. And then when you divide by 1,000, when your fraction has 1,000 as a denominator, you are moving your decimal point to the left 3 places. 1, 2, 3. So our answer is 0.344 liters. All right, now if we wanted to use a unit rate, it would look a little bit different. We would start with the number they gave us, which was 344 milliliters. And when you use a unit rate, you always multiply. So I'm going to multiply by the unit rate. The tricky part of using this strategy is you have to know which unit rate you are using. So I have milliliters and I would like to get liters. So I have milliliters, I would like to get liters, turn it into liters. So I need to multiply by this unit rate, which is 1 over 1,000. So 1 liter for every 1,000 milliliters. Okay, so my milliliters cancel out, and I end up with liters on the top, so that's how I know my unit is liters, and I end up with 344 times 1, which is 344. My denominator is 1 times 1,000, which is just 1,000. So we end up with 344 over 1,000, which we had right here in this problem. And we know we can just take that 344.0 and move our decimal place 3 places to the left, because that's how you can solve dividing by 1,000. And so we get the same answer of 0.344 liters. So there we solved it 2 different ways. Number 4 and 5, we get to solve any way we want to. I'm going to use the unit rate method just because I feel like it takes up a little bit less space. So number 4 says a bottle contains 1.89 liters of water. How many milliliters is this? So since I'm using my unit rate strategy, I'm going to start with what they gave me, which was 1.89 liters. I always multiply when I'm using a unit rate, and I need to turn it into milliliters. Now, when you're trying to decide which unit rate to use, you always want to use the one that will cancel out your unit. So if I have liters on my numerator on the top, I want the unit rate that has liters on the bottom. Is that my one on the left or the one on the right? It's the one on the left right here. Liters is on my denominator. And that unit rate is 1,000 milliliters for every liter. So now my units cancel and I'm left with milliliters. And to solve this, I have 1.89 times 1,000. Well, 1.89 times 1,000, when I multiply by 1,000, you're moving your decimal point to the right 3 places. On the last problem, our decimal point was going to the left 3 places because we were dividing by 1,000. Now we're multiplying by 1,000, so we go to the right. 1, 2, we need to go another place, which means I need to add a 0 onto the end of my number. So I have 1,890 milliliters. So 1.89 liters of water is the same as 1,890 milliliters of water. Number 5. A soap dispenser holds 220 milliliters of soap. A refill bottle of soap contains 1.76 liters. How many times can the dispenser be refilled from the bottle? Okay, so this is going to be a multi-step problem because I need to do my conversion to either have both of them be liters and both of them be milliliters, but then I will need to do an additional step to figure out how many times the dispenser can be refilled from the bottle. Okay, so it's like you have a dispenser is on the wall, maybe at school, and you have a big bottle of soap, and you're like, oh, Miss McPeak, the soap's out. What do we do? Oh, we need to pour more from the bottle into the dispenser. So we're going to see how many of these bottles are we going to need to fill up this dispenser. Or how many dispensers could be like, it depends on which one's bigger. We can have lots of dispensers filling up from the bottle or lots of bottles used to fill up the dispenser. It could be either time. Either way, that's what we're going to be figuring out. So first, we need to make them the same unit. We can make them both milliliters or we can make them both liters. I think I'm going to decide to make them both liters. It really doesn't matter. So I'm going to take this 220 milliliters and I'm going to turn it into liters by multiplying it by the unit rate. Which unit rate do I use? Well, I have milliliters, so I want to do the one that will cancel out those milliliters. So the one with milliliters on the bottom is this one. So multiply it by 1 over 1,000. And that will give us 220 divided by 1,000 because our milliliters will cancel out. So 220 divided by 1,000 equals 220 moving our decimal point 3 places. Basically, it's 0.220, which is the same as 0.22. Okay? All right, I made another mistake, so I had to scribble it out. I didn't want that in my video. So instead, I'll just keep going, pretend that big blob is not there. All right, and what we're going to do is we want to figure out From this 0.22 or 0.220, it's the same thing, how many will fit of the bottle of soap and that dispenser. So what we're going to do is we're going to take our 1.76 from our bottle of soap, and we're going to divide it by 0.22 because we want to see how many of those dispensers we're going to get into that bottle. So if the decimal's on the side, slide, slide. Remember, you copy the movements of your decimal on your divisor and your dividend. And now we have a decimal in the house, so we're going to raise it to the roof. And this looks kind of messy, so as you guys know, I like to rewrite it so it looks nice and clean. So I have 22 as my divisor, and my dividend is now 176, with our decimal point being right here. And we will raise that to the roof. All right. 22 does not go into 1, it's not going to 17, but does it go into 176? Yes. How many times? I don't know. I know that 22 is close to 20, so if I'm estimating, I can count by 20s. 20, 40, 60, 80, 100, 120, 140, 160, 180 would be too much, that would be 8, but we're working with groups of 22, so let's try that instead of 20. So 8 times 2 is 16. 8 times 2 is 16, plus 1 more is 7. No way, this works perfectly. Awesome. So we have nothing left. That means if we wanted to put our 0.0 out here, we could, but really, it's just going to end up zeroing out anyway. 8.0 is the same as 8. So what we found out is how many times can the dispenser be refilled from the bottle? 8 times. All right, so there's a lot of soap in that bottle. You can fill up the dispenser of soap on the wall in the classroom 8 different times before that bottle runs out. Okay, so this should maybe bring you back to some 4th grade math. At least when I taught 4th grade, we worked a lot with these. Customary units of liquid volume, quarts, pints, gallons, cups. Maybe you remember gallon land or gallon man, some of those kind of silly ways of remembering all of these things. They did help us out with a little chart. 2 cups equals a pint, 2 pints equals a quart, and 4 quarts equals a gallon. So we are going to use this information to help us solve some of these problems. Number 6 says, write 2 unit rates relating quarts and gallons. Okay, so quarts versus gallons. I know that 4 quarts is the same as a gallon, so one of the unit rates I could write would be 4 quarts per gallon. So that would be one of the unit rates. The other unit rate would be everything reversed or inversed or making a reciprocal. So instead of 4, it would be 1/4 gallons for every 1 quart. And so that would be the other one. Those are the 2 unit rates right there. Number 7 is how many quarts would it take to fill a 2 3/4 gallon punch bowl? Okay, how many quarts would it take to fill gallons? I think if they want to know how many quarts, we need to turn this into quarts. So I want to know how many quarts is 2 3/4 gallons, okay? So I have gallons, I want to turn it into quarts. I have 2 3/4 gallons, and I want to turn it into quarts. So I need to pick the unit rate that has gallons as a denominator, which is this one right here. So I'm going to multiply by my unit rate. So multiply it by 4 quarts per gallon. My gallons will cancel each other out. And now I have a new multiplication problem of 2 3/4 times 4. So I need to turn this into an improper fraction so I can actually multiply my numbers. So I'm going to do my backflip. 4 times 2 is 8, plus 3 more is 11. So this turns into 11/4 times 4, which is the same as 4/1. And that simplifies into, my numerator becomes 44, 11 times 4, and my denominator becomes 4. 4 times 1 is just 4. And 44 divided by 4 is 11. So if I turn my gallons into quarts, it is 11 quarts. Number 8. One of the cows on Tessa's farm produces an average of 22 quarts of milk each day. How many gallons is this? So we want to turn the quarts into gallons. So we have 22 quarts and we want to turn them into gallons, so we will multiply by the unit rate that has the quarts in the denominator, which is this one right here. So we're going to multiply it by 1/4 gallons per quart, and we picked that because now we can cancel out those units, because when you have one in the numerator and one in the denominator that's the same, they go away because they equal 1. So we're left with gallons, and so we can rewrite this as 22 gallons divided by 4, because 4 was our denominator. Now you could solve 22 divided by 4 probably in your head. I know 4 times 5 is 20, and then we would have 2 left over, and the denominator would stay the same, so it would be 5 2/4, which is the same as 5 1/2. And we are working with gallons. All right, number 9. How many pints are in 1 gallon? Oh, okay, so we have an extra step here. How many pints are in a gallon? Now you could do this with unit rates. Personally, I think that these numbers are maybe small enough to figure out without using unit rates. I can see pints. Well, 2 of them would equal a quart, and there's 4 quarts in a gallon. So I'm going to do a little picture. Maybe you guys remember this from your 4th grade class of gallon land. So here's 1 gallon, and in that 1 gallon, there's 4 quarts. So I'm going to do 4 quarts. Okay, so 4 quarts equals a gallon. And then in every single one of those quarts, there's 2 pints. So I could have solved this with unit rates, but I thought I'd bring back your memories of 4th grade if you had a teacher that did it like this. So how many pints ended up being in that gallon? 1, 2, 3, 4, 5, 6, 7, 8. So 8 pints in our picture were in that gallon. So our next question says, use your answer to question 9, which was this, to help you write 2 unit rates relating pints and gallons. Okay, so there are 8 pints in a gallon. So that's one of the unit rates. The other one would be the opposite. 1/8 of a gallon is equal to a pint. So the next question is going to have us use that. The school cafeteria sells 300 half-pint cartons of milk every day. How many gallons of milk is this? Okay, I think there's a little bit of a trick here because they're not saying pints, they're saying half pints. So I think in our answer, once we get the pint answer, we're gonna have to divide it by 2. This is a little bit tricky. Okay, so we're basically turning 300, I'm just gonna pretend it's pints, we'll deal with the half later. 300 pints, we're gonna figure out how many gallons is that. So pints to gallons means we're gonna take 300 pints, multiply it by the unit rate with pints on the bottom, the denominator. So 1/8 of a gallon per pint. The pints cancel out, and we end up with 300 gallons over 8. Now I don't know 300 divided by 8, so I'm going to do that math right now. I have some room up here, so I'm going to use it. 300 divided by 8. Let's see, 8 times 4 is 32, so I can only fit 3 groups. 8 times 3 is 24. Subtract and I get 6. Bring down my 0. 8 times 8 is 64. That's too much, so we'll do 8 times 7. 7 times 8 is 56. Subtract and we get 4. So I have a remainder of 4, or I could say my fraction left over is 4/8, which is the same as 37 and a half. Okay, so here's what we found out. 300 pints is 37.5 gallons. But 37.5 gallons is not our answer because the school sells half pints, which means we need to find the halfway point of 37.5. So I have an extra step. I'm going to take 37, I'm going to write it as a decimal, 37.5, and I'm going to divide it by 2, because dividing by 2 is the same as finding the halfway point. So let's do this extra calculation here. 2 goes into 3 one time. 1 times 2 is 2. Subtract, we get 1. Bring down our 7. 2 times 8 is 16. Subtract, we get 1. Bring down my 5. Oh, I'm running out of space. I should have known that. Oh, I have a decimal in the house. I need to raise it to the roof. 2 goes into 15 7 times. 7 times 2 is... Whoa, I ran out of space. This should say... I'm just going to scoot it over here. 15. 2 times 7 is 14. Subtract, we get 1. I really did terrible with my spacing here. I'm sorry. Put down another 0. Woo, bring down my 0. 2 goes into 10 5 times. I'm not going to finish it out. I already squashed it enough. Sorry. But all that to say, how many gallons is this? Well, the pints was 37.5 gallons. So if we have a half point, it's half that amount, which is 18.75 gallons of milk. All right. Which is more, 72 cups or 20 quarts? And explain how you found your answer. Well, there's more than one way to do this. It depends on if you want to turn everything into cups or turn everything into quarts. So right now, I think we need to figure out first how many cups are in a quart. So I'm going to draw a little picture, just like we did on Gallon Land. Again, I could be using unit rates, but I think this is a little bit more fun. If I have a quart, there's 1 quart, and in my 1 quart, it says there's 2 pints, and inside each pint, it tells me there's 2 cups. Okay, so in my picture, basically what I found is if you want to compare cups to quarts, we have 1 quart has 4 cups in it. So that tells me that my unit rate is 4 cups per quart, or 1/4 quart per cup. Okay, so both of these are my 2 important unit rates that I could use for this activity. So I'm going to make everything quarts, just because I can choose. I could make everything cups or I can make everything quarts. I'm going to make everything quarts. So I'm going to leave my 20 quarts alone, but I'm going to turn my 72 cups into quarts so that they're both quarts. So 72 cups, multiply it by my unit rate. I would like my cups to go away, so I'm going to use the cups with a denominator, which is the second one. So multiply it by 1/4 quarts per cups. Now my cups cancel each other out, and I end up with 72 over 4 quarts. Well, 72 over 4, I don't have that memorized, so I'm going to do that real quick. 4 times 1 is 4, subtract, we get 3, bring down my 2. 4 times 8 is 32. Oh, I love when I don't have a remainder. We get 18 quarts. So basically what we just found out is 72 cups is the same thing as 18 quarts. So which is more, 18 quarts or 20 quarts? The 20 quarts is bigger. And the reason we know it is because we changed our 72 cups into 18 quarts, and 20 quarts is more than 18 quarts. So our answer is which one is more? 20 quarts. All right, next page. The most common units of mass are grams and kilograms. So first it says, we're going to make a little conversion here. 1 kilogram equals 1,000 grams. That's just something that if you haven't learned yet, you should know. And the opposite of that is true as well. 1 gram equals 1/1000th of a kilogram. So the 2 unit rates relating grams and kilograms are 1,000 grams per kilogram, or 1,000th of a kilogram per gram. Notice the two unit rates are always kind of inverse from each other. For number 15, it says convert 3,575 grams into kilograms. Okay, so I have grams. I would like to turn it into kilograms. So I would like to pick the one that has grams in the denominator so it'll cancel out, which is this one. So I'm going to use this unit rate. So I have 3,575 grams multiplied by the unit rate of 1/1000th kilograms over grams. My grams cancel out and I'm left with 3,575 divided by 1,000, which is 3,575 divided by 1,000. I'm moving my decimal 3 places to the left. 1, 2, 3. I get 3.575 kilograms. For my next one, I want to take my 3,575 kilograms and turn it into grams. So take my 3,575 kilograms, and I want to pick my unit rate that has kilograms on the denominator, which is the first unit rate. So I'm going to multiply it by 1,000 grams for every kilogram. My 2 kilograms cancel each other out because one's on the numerator, one's on the denominator. And now I have 3,575 times 1,000, which is that same number, but I get to add 3 zeros to it. Now, what is that giant number? 1, 2, 3, comma, 1, 2, 3, comma. It's 3,575,000 grams. That's a really big number, but that's what it is. Number 17. A nickel has a mass of 5 grams. A bag contains 2 kilograms of nickels. How many nickels are in the bag? And then we have to explain. All right, so this is definitely going to be a multi-step problem. But first, we got to decide, are we going to do everything in grams or in kilograms? It doesn't really matter. You can choose. I'm probably going to pick, let's do everything in grams. Why not? So I'm going to keep this 5 grams. I'm going to leave it alone. But I'm going to turn these 2 kilograms into grams. So 2 kilograms, I'm going to multiply it by the unit rate that has kilograms in the denominator, which is this one, the first one. So times it by 1,000 grams per kilogram. My kilograms cancel out and I'm left with 2 times 1,000, which is 2,000 grams. Okay, a nickel has a mass of 5 grams. A bag contains 2,000 grams of nickels. So we turn that 2 kilograms into 2,000. How many nickels are in that bag? So now we get to do the step of division. We get to say, what is 2,000 divided by 5? Because if there's 2,000 grams in the bag and 5 grams per nickel, if we divide, we'll figure out how many nickels there are. So 5 goes into 20 4 times. Subtract and we get 0. Bring down a 0. 5 goes into 0. 0 times. 0 times 5 is 0. Subtract and we get a 0. Bring down our other 0. 5 goes into 0. 0 times. 0 times 5 is 0. 0 minus 0, 0. That was a lot of zeros. But we ended up with 400. So how many nickels are in the bag? 400 nickels. Number 18. The most common units of weight are ounces and pounds. There are 16 ounces in 1 pound. Write 2 unit rates relating ounces and pounds. All right, 16 ounces per pound. That's our first one. And then the other one is the inverse, 1/16 pounds per ounce. Now actually, my 16 and my pound LB, they look a lot alike. Need to make sure my B actually looks like a B and not a 6. Anyways, now we're going to convert 420 pounds into ounces. So if we start with pounds, we want to multiply it by the unit rate that has pounds in the denominator, which is the first unit rate or the second one? Yeah, the first one has pounds in the denominator. So we're going to take 420 pounds, multiply it by our unit rate of 16 ounces per pound. And then our pounds cancel out. We're going to be left with ounces. So we just need to solve 420 times 16. I'll do that over here on the left. 6 times 0 is 0. 6 times 2 is 12. Carry the 1. 6 times 4 is 24. 1 more is 25. Placeholder. 1 times 0 is 0. 1 times 2 is 2. 1 times 4 is 4. And we add for our last step and get 6,720 ounces. Number 20. Now we're going to convert 420 ounces into pounds. So if I have 420 ounces and I want to multiply it by the unit rate, I want the one that has ounces in the denominator. Which one is that? It's my second one. Ounces are in my denominator. So I'll multiply it by 1/16 pounds per ounce. My ounces cancel each other out and we're left with pounds. So this becomes 420 over 16 pounds. Now what is 420 divided by 16? I have no idea, so I have some math to do. 420 divided by 16. Well, I know 16 times 2 gets me to 32. If I subtract, I'm left with 10. Bring down my 0. 16 goes into 100. I don't know, I think 15 times 5 is 75. So 15 times 6 must get me to 90. I don't think I can really fit more than that. So 6 times 6 is 36. 6 times 1 is 6. Plus 3 more is 9. Yeah, so we got to 96. That's about as close as we can get with the remainder of 4. So 26 and 4 over 16, because 16 is our divisor. And I know 4/16, that could simplify to 1/4, because 26 and 4/16, 4 and 16 both share a factor of 4. So this could divide by 4, and this could divide by 4, and that would give us 26 and 1/4 for our final answer. So 420 ounces is the same as 26 and 1/4 pounds. All right, number 21. Donnell adopted 2 puppies. Oh, lucky Donnell. Daisy, must be the name of a puppy, weighs 7.5 pounds. Bandit weighs 108 ounces. Which puppy weighs more? Well, in order for us to compare how much they weigh, we have to know if they're both going to be pounds or both going to be ounces. I'm going to turn 7.5 into ounces. Why not? Okay, so 7.5 pounds. I would like this to be ounces. We're going to keep 108 the same because it already is in ounces. So 7.5, I like working with decimals better than fractions, so I'm going to write it as 7.5 pounds. And we're going to multiply it by the unit rate that has pounds in the denominator, which is this first one. So multiply it by 16 ounces per pound. My pounds cancel out, and I'm left with 7.5 times 16. All right, 6 times 5 is 30. 6 times 7 is 42. 3 more is 45. 1 times 5 is 5. 1 times 7 is 7. And we're ending up with 1,200, which seems really heavy, but that's because it's ounces, and I haven't dealt with my decimal yet. So I have 1 decimal movement in my factor, so I get 1 decimal movement in my product, and I end up with 120. So if I have 120 ounces is what Daisy was. Daisy is 120 ounces. And Bandit, we already know, was 108 ounces. Who actually weighs more? Who weighs more? Daisy does, because Daisy weighs 120 ounces, which is more than Bandit. Some kids might have just said at the beginning, oh, Bandit weighs more, because 108 is more than 7.5. But they weren't the same unit of measurement, so you couldn't really compare them until you made them both ounces or both pounds. All right. Last page of problems for the day. Number 22. So this is basically the problems we've been doing all along. It's just mixing up all the units of volume, of liquid volume. It's just changing which ones we're using each problem. Number 22. A box of Fruit Blasters cereal contains 450 grams of cereal. How many kilograms of cereal will the company need to fill 15,000 boxes? Okay. Well, first, it's asking kilograms, so we need to turn this 450 grams into kilograms. So 450 grams, we're going to multiply it by the unit rate that has grams in the denominator. So let's go look. Here's our 2 unit rates. Grams in the denominator is this one. So 1/1000 kilograms per gram. So our grams cancel out, and we are left with 450 kilograms for 1,000, or over 1,000. And when we divide by, when it's over 1,000, that means divide by 1,000, which means 0.450, which is the same as 0.45 kilograms. Because remember, when you have this and you're dividing by 1,000, your decimal place just goes over 3 times. 1 time for every 0. All right, so we end up with 0.45. Okay, but that's not the question. The question is, how many kilograms of cereal will they need to fill 15,000 boxes? Oh my gosh. Well, 1 box of cereal contains 0.45 kilograms. Well, if they want 15,000 of those, our last step is to repeat 0.45 15,000 times. So we need to do 15,000 times 0.45. 5 times 0 is 0. 5 times 0 is 0. 5 times 0 is 0. 5 times 5 is 25. 5 times 1 is 5. 2 more is 7. Placeholder. 4 times 0 is 0. 4 times 0 is 0 again. 4 times 0 is 0 again. 4 times 5 is 20, which has a 0. Oh my goodness. 4 times 1 is 1. 2 more is 3. Sorry, not 4 times 1 is 1. My mistake. 4 times 1 is 4, plus 2 more is 6. Oh man, I almost messed up at the very end because I was getting too fast. So I'm adding, and I end up with 675,000, which is really big, so I have to deal with my decimal. 1 2 decimal movements, and my answer gets 1 2 decimal movements. So right there, 6750 decimal. 6750. I'm not going to put my decimal because after my decimal was just zeros. So how many kilograms of cereal will the company need to fill 15,000 boxes? 6,750 kilograms of cereal. Letter B. So along with that, how many boxes of cereal can the company fill with 15,000 kilograms of cereal? So this is like the opposite question. Now we have 15 kilograms of cereal. How many boxes can that fill? So now we do 15,000 divided by 0.45. So we are going to take our decimal and say if the decimal's on the side, slide. So we get to add 2 more zeros on there. And if the decimal's in the house, we raise it to the roof. All right, Does 45 go into 1? No. Does it go into 15? No. Does it go into 150? Yes. 3 times. 5 times 3 is 15. 3 times 4 is 12. 1 more is 13. All right, subtract 150 minus 35 and we get 15. Bring down our 0. Hey, we just did this. How many 45s go into 150? 3. We found out it was 135. Subtract and we get 15. Bring down our 0. Hey, this looks familiar. How many 45s go into 150? 3. 3 times 45 is 135. Subtract and we get 15. Hey, bring down another 0. This is getting crazy. 45 goes into 150 3 times. 3 times 45 is 135. Subtract and we get 15. Bring down another 0. And 45 goes into 150 3 times. 3 times 45. Hey, surprise, is 135. Subtract and we get 15. And you know what? I think this is going to keep going and going and going and going. I predict it's going to be 0.33. It's just going to keep going. But the idea is, how many boxes can they fill? 33,333 boxes. Now, I could put decimal 0.33333, but if they just want to know how many boxes can get filled up, well, this is how many can get full. You would have a third. 0.33 is the same as the fraction 1/3. A third of the next box could get full, but it wouldn't get all the way filled. So the ones that get completely filled are 33,333 boxes. That was a crazy problem. Okay, number 23. A perfume bottle holds 5 milliliters. The perfume company wants to fill 25,000 bottles. How many liters of perfume will the company need? All right. Well, first we should figure out how many liters are in 5 milliliters. Let's do 5 milliliters times the unit rate connecting milliliters and liters, which was here. And we want the unit rate that has milliliters in the denominator. That's this one, 1 over 1,000. And that would be liters per milliliter. Okay, so our milliliters cancel out, and we end up with 5 over 1,000 liters. Well, 5 divided by 1,000 is just this. 5.0 divided by 1,000 means we have to move the decimal place to the left. So 1, 2, 3. So we have to be careful on this one. My decimal's here, but I ended up adding a couple of decimal places. So it's 0.005. So one perfume bottle holds 0.005 liters of perfume. How many liters of perfume will the company need for 25,000 bottles? So our next step is to take 25,000 and multiply it by 0.005. Now the nice thing about this number is I could just multiply it by 5 and then deal with my decimal later. I don't have to put all these extra zeros in there. 5 times 0, 0, 5 times 0, 0, 5 times 0, 0, 5 times 5 is 25, carry my 2. 5 times 2 is 10, 2 more is 12. Now, multiplication, my answer has, my factors have 1, 2, 3 decimal movements in the factors. So 1, 2, 3 of them in the product. So how many liters of perfume will they end up needing? It ended up just being 125 liters. That's how much perfume they need to fill up 25,000 bottles. Number 24 says Zeke's little sister's trying to fill her wading pool using a 1-cup container that she fills at the bathroom sink. If the pool holds 70 gallons, how many times will she have to fill her container to completely fill the pool? All right, so we have this tiny little cup, and we want to figure out with all those gallons, how many times she would need to fill it up. Oh my goodness, this poor baby sister, you guys. if there's 70 gallons in the pool, how many times is this little sister gonna have to fill up that one little cup container? I'm gonna tell you something. It's gonna be a lot of times. But we need an equation that matches cups to gallons. I would like these gallons to turn into cups. Did we have one of those? Ooh, we did not. Okay, so I'm gonna figure that out really quick. Here is a gallon. There's 4 quarts in my gallon. And there's 2 pints in every single quart. And there's 2 cups in every single pint. It's really probably hard to see on the camera, but those are 2 cups, 2 little C's I'm putting in every single P or every single pint. So how many cups are in a gallon? 1 gallon equals 16 cups, because I see 4 right there. So 4, 8, 12, 16. Okay, I'm going to need that. 1 gallon equals 16 cups. So the 2 unit rates then, comparing gallons and cups, are 16 cups in 1 gallon, or 1/16 gallon per cup. Those are kind of my 2 choices. So which one? Do you guys see that lovely big blob of blue right there? That's because I made a giant mistake. The first time I wrote this, I did all this work, and I started as 70 cups instead of 70 gallons. That messed up my whole thing. That was silly of me. Okay, 70 gallons, there we go. I'm going to multiply it by the unit rate that has gallons on the denominator, which is my first one that I wrote over here. So multiply it by 16 cups for every gallon. Those gallons will cancel out, and I end up with 70 times 16. I don't know 70 times 16, so I'm going to figure it out. 6 times 0 is 0. 6 times 7 is 42. Placeholder, 1 times 0 is 0. 1 times 7 is 7. Add my numbers together, and I get 1,120. So 1,120 times, and the reason I know that's true is because if this pool is 70 gallons, and that's the same as 1,120 cups, and she's filling it up with 1 cup at a time, well, if it's 1,120 cups, and she's working with a 1 cup measuring tool, this poor little sister is going to fill up her wading pool 1,120 times. I'm pretty sure she's going to give up. That's just my opinion. But hey, maybe she's persistent. Maybe she's like me. She makes a mistake and then keeps going. Even though she made a mistake to use a 1 cup, she kept going. Kind of like I made a mistake here with this big ugly blob and I kept going. Okay, number 25. There are 75 6th grade students at Wilson Middle School. Each student has a science book that's 5 centimeters thick. If all the 6th graders stacked their science books on top of each other, would the stack be as tall as the 4-meter tall school building? Explain. All right, I would like to know how many centimeters is their building. So I'm going to take this 4 meters and multiply it by the unit rate that connects meters and centimeters. And since that's not a measure of liquid, it's a measure of distance. That's actually from our lesson that was before this lesson. So meters and centimeters, I believe we have that somewhere. We have a unit rate. I know it's 101. I was just going to show it to you guys. No, we didn't even do it yesterday. Okay, well, I'll do it right now. Meters and centimeters. Well, I know that 100 centimeters equals a meter. And I'm just going to use this unit rate. I don't even need to write the other one, 100 centimeters per meter, because I want the one with meters on the denominator. which is this one. So 4 meters times 100 centimeters per meter. Meters cancel out, and we end up with 400 centimeters. So the school is 400 centimeters tall. So the 75 sixth graders are going to stack all their science books that are 5 centimeters thick on top of each other. So we're going to see how tall that is. So if we have 75 kids stacking their 5 centimeter books, what's 75 times 5? Because 75 kids, 5 centimeters for each book. 5 times 5 is 25. 5 times 7 is 35. 2 more, 37. We get 375 centimeters. So basically, we have all the books would be 375 centimeters. And the building is 400 centimeters. So the question is, if they stacked all their science books, would it be taller than the building? Nope. Because the building's 400, their books would be 375. They would be 25 centimeters short. All right, guys, that's it. Sorry for the big scribble that I had, but oh well, it happens. Hopefully this lesson made sense to you. If you have any questions, let me know.